Hello guys, my name is Arash. Welcome to my YouTube channel Data to Deploy. In this video I want to talk and show you how you can build a signal filtering bot with machine learning and Python programming language. So recently I have wrote an article about machine learning in trading, and I talked about machine learning is not about predicting the exact price, but it's a tool to help us in our decisions. So there are lots of spaces machine learning can help us in finance, for example filtering signals, or estimating the probability, or using dynamic risk management, or optimizing our bot entry to reduce, for example, a slippage or fees, or detect the regime changes. So one of the topics are signal filtering, which is a rule-based strategy that might generate lots of trades, but with machine learning we can improve our decisions, and instead of, for example, trading 200 trades in a month, with machine learning we can reduce it to maybe 60 trades per month, but the right trades. Okay, instead of trading noise, with machine learning we can improve our decision boundary, and instead of trading multiple time we reduce the amount, but we enter on a very good trade. In this video I want to show you how you can build such a thing with Python and using machine learning, so keep watching. Before we jump in and see how we can develop such an app, I will show you later in the video. I want to tell you you can read the full blog on my website Data to Deploy. You can just simply open this website. I put the blog link in the description. You can simply open the blog and then click on the article, and here, as you can see, I explained everything for you in this blog, and I put all the codes, all the roadmap, how your directory should look like. You can use all of this code yourself and test it. Also, I have added this code to my GitHub account. You can check it on my repositories. Here, as you can see, all the codes here. You can simply clone it on your own machine or your server and run the code, and if you want you can make some changes and fork it here. Okay, let's talk about our application I have written, and see how it performs, how it works. So basically, first thing you should do is to create a virtual environment. If you don't know what is virtual environment is, I put the link in the description. You can go and read about it. Basically, virtual environment, when you create it, as you can see here, in the parentheses .vm is telling that the virtual environment is activated in my directory. So for example, if I run ls-a, you can see here the .vm means I have installed virtual environment in this directory. So when you want to install libraries specifically for that project, you create a virtual environment and run your project in that environment, so other applications on your machine or on your server will not have a conflict with this application. For example, you want to install different Python version for your this application, but for another application you want to use older version. For example, here I can see the Python version for this project is 3.14.2, but maybe for another application you need to have Python 3.12. Okay, so when we create virtual environment, all the libraries, all the versions are specific to that project and environment. It's very important when you want to work on something to have a clean environment. Okay, how you can create your virtual environment? First, let me deactivate our virtual environment. With running deactivate, your environment will be deactivated. You will run python 3-m vm.vm. Let me check it. Yes, you hit enter and your environment will be created, and with source vn/bin/activate your environment will be activated. Here, as you can see, .vm show us that our application, our environment have been activated. So right now we are in our virtual environment, so you need to create some directories. Here, as you can see, inside our directory it's running make directory, for example btcml filter. When you hit enter, a new directory will be created, and with cd and our directory name, we go to that directory. So before you create your virtual environment, first create your directory and then run the virtual environment installation command inside that directory where you want to install or run your application. So after we move here, we should create our directories. For example, for our this specific application, we need one directory for data, one directory for models, one directory for plots, one directory for src, which our main logics stay here, and two Python file without directory, main and config file. So simply you run make directory, for example data, you hit enter. Because I already have one, it said to me file exists. Or make directory src, again because I have the file, it said the file is exist. Or for example, for generating a Python file, you simply run nano, for example main.py. Here, as you can see, I have some codes here, but when you run it for the first time, you get an empty file, then you can paste or add your codes. So because I don't want this video be too long, I have the code and application ready, and we want to talk about how it works, and then you can easily come here and copy paste this code. For example, here, as you can see, for src download data, this is the logic how you can fetch Bitcoin price data from Binance exchange into your local machine. Okay, so you can copy this and paste it in your download data here, as you can see. And for example, here you can choose which time frame you want to download the data, your limits, because when you want to get data from exchange APIs, you have some limits. If you increase this, you will get error, and exchange gives you 403 error. And other part, for example, for feature engineering, which get the raw data. For if I want to, I can show you Candlestick. Let me open this. As you can see, this is a candlestick in trading. Okay, each candle has 4 parameter, the open, the close, the high, and the low. And again, for the bearish candles, it's opposite. Here is open, here is close, and this is low, and this is high. Okay, so with feature engineering, we gather this data which we get from the exchange, and we generate multiple features from this raw data. Okay, for example, we use our closed data or our open data and generate, for example, volatility of that asset, okay, or momentum of that asset. This, we call this feature engineering. Okay, you can just simply copy this code and paste it in your feature engineering.py. And also for other part, for example, for our signal generation logic. Okay, for example, we say if RSI go below 30 or RSI go higher than 70, or for example, if the price closed below the 10 before 10 days, the previous 10 days mean, you go into trade, enter the trade. Okay, you can write any logic you want. This is the experimentation, so I choose a simple logics so you can understand better. And all other parts, for example, here is label generation is another thing. You can copy this and paste it in your file. Let me find it. Okay, the file name is create labels. So basically with this file, here as you can see, this part for example, give 1 if our feature return is higher than 0.5%, and give 0, which one means profitable, and otherwise 0, which means it's not profitable. And other important part is our train model Python file, which we run our model with it. Here as you can see, we import libraries we need. For example, our XGBoost classifier, for example, train test split, which for machine learning models you should split your data, for example, 80% to training and 20% for testing. And for example, our classification report, and here as you can see, for example, we give our features column into X variable, and our target column to Y variable. And this is called supervised learning in machine learning, which we have a label or a target column. We want to train our model to predict the future labels. Okay, and here as you can see, we split our data into train and test, 20% for test size and 80% for training. We give our model some inputs, for example, number of estimators, max depth. I have wrote a blog about machine learning models. I put the link in the description. There you can understand how XGBoost works, or other machine learning models. And we fit our model on train data, and then we predict on our test data. And after that, and our main file, here as you can see, our main file is running all the logics in one file. Okay, because we could I could write all the codes in just one file, but it got very messy, so I decided to write into separate files, so our application has a better management, and debugging it is way more easier. Here, as you can see, for example, we get our data frame. Here we import each function in src file. For example, our download data, the function name is download data. Here we import it, src.download data, import download data, and here we say, for example, our data frame, and when we mention our function, all the logics inside here we run, and at the end, as you can see, it returns a data frame. So here we get our data frame, and after that, for example, we run our feature engineering, and then we generate signals, and then we point labels, we clean data, we save data into a CSV file, we train our model on our data frame, and for example here we separate our signal rows where the signals tell us it's profitable after our machine learning model learned the data frame, and we print some variables, and as you can see right now our code is ready. You simply, with running python 3 main.py, you can run the application and see your result. We wait a little. Main.py includes all the logics we have, and we can simply call main.py to run our application. We wait a little. Here, as you can see, previously I tried to run, but because I tried it before, I get error, max retries exceed, so I changed my network, and now here, as you can see, still I get error. Let me fix it and I will come back. Okay, I changed my network and I run the command again, and here we are. Our application starts, runs, and here you can see our results. For example, this is the classification report. We have two outputs. So classification basically means we have, for example, 0 or 1, yes or no, true or false. Okay, we call this classification. But regression means the model, or the goal of us using machine learning is to predict a consistent value, for example a stock price or regression. But in this situation we want to see whether, for example, the next candle is green or red, profitable or not profitable. 1 means it's profitable and 0 means it's not profitable. And here, for example, as you can see, the model we run is basically choose most of the trades as not profitable and a few one as a profitable. Here, as you can see, for example, based on the time range we download data, we have 952 candles, which after some filtering gets to 515, and the filtered signals, which are the signals our XGBoost model choose, are 44. Here, as you can see, out of 952 candles, 758 ones are 0, which means non-profitable, and 194 of them are profitable. And here, as you can see, we can see the probability of our outcome. I can also show you in the images inside plots. We generate images. Here, as you can see, out of 517, raw signals. The mean is 0.14, and here as you can see our data had a right squid. And for example, if we click on signal, here as you can see, these blue arrows are the prediction. Our static strategy without using machine learning, you can see we have lots of trade signals, but when with using machine learning, our signals decrease, but better ones, we get better entries. So this is not basically a full trading system. This is just talking about how we can use machine learning to improve our entry logic. Okay, because of that we don't have exit signals here, but as you can see, and also we didn't optimize our machine learning model parameter. This is a raw ML improvement. And here with feature importance, we can see that the volatility column from our dataset which we generated with feature engineering gives us the highest point, which means that these columns help us in predicting the market, predicting our profitability higher than other features. After that is momentum column, then RSI, and after that volume ratio. For example, in our model, in our strategy, here as you can see, for example, our moving averages, exponential moving averages didn't give us much help for predicting trades, but these four columns give us the highest scores. And in data, you can see here the data we have downloaded from the Binance exchange. This is the full data, and 952 rows of data, and these are just 44 of them which are machine learning filtered. And that's it. We talked about how machine learning can improve our trading decisions, reduce our number of trades into better decision making, and improve our trading results in future. Thank you guys. I hope you like this video. Please leave a comment, tell me your idea, what improvement I can do on my videos, and what do you want to I talk about and I create video about it in future videos. And also don't forget to click that subscribe button and like this video. Thank you. Bye for now.